Hi everybody, this video is going to talk about linear inequalities. So a couple things before we start taking a look here. A linear inequality is going to be very similar to a linear equation, but it uses an inequality symbol instead of an equal sign. So just as a refresher here, we have four inequality symbols. We have the less than symbol, less than or equal to, greater than or equal to. So these are the four inequality symbols you'll see appearing here. Now, our goal is going to be to find the solutions to the inequality. Now, there's going to be more than one answer, okay? The solutions are all of the ordered pairs that make the inequality that we're given true. So let's see what that means. All right, so here's an example of a linear inequality. You can notice we have the less than symbol here. We're trying to figure out which of these points are solutions to that linear inequality. So we can test by simply plugging in the x and the y values. If I plug in 2 for x and 5 for y, I'm checking to see if this left side is actually less than 15. So we would get 4 minus 15, and when we subtract, we get negative 11 is less than 15. Well, yeah, that's true. Negative 11 is smaller than 15. So that means that 2, 5 is a solution to that inequality. So that's what we're doing for each of these points here. So let's check the next one. Here's x and y. We plug them in. 2 times negative 1 minus 3 times negative 7, checking to see if that's less than 15. So we get negative 2 plus 21. Well, negative 2 plus 21 is 19. 19 is not less than 15. Okay, this is not true. So that means this is not a solution to that inequality. So you get the idea here. There's two more that you can try on your own. For 3, negative 4, you should find that this is not. And for 0, 0, you should find that, yes, this is a solution, again, by plugging in the x and y values and testing. So you can try that on your own. Most of the time when we have a linear inequality, we're going to be actually graphing the linear inequality to find all of the ordered pairs that are solutions, and we have some steps below. So step 1 is we're going to put the inequality that we have into slope-intercept form. So that should sound familiar because that's our y equals mx plus b. And just like if we had a line, we would want it to be in slope-intercept form before we graph it. Same with our linear inequalities here. Now, something that you're going to have to keep in mind, and this takes us back to earlier in the year when we were talking about inequalities, if we ever multiply or divide by a negative number, we're going to have to flip our inequality symbol. Okay, so we have our line or our inequality in slope-intercept form. We're ready to graph. We graph our line as usual, but we have to be careful here. Okay, there's two things that are going to be different. When we graph our line, we're going to use a solid line, meaning like completely connected, if we have the less than or equal to symbol or the greater than or equal to symbols. We're going to use a dashed line if we have the less than symbol or the greater than symbol. And then we're going to do something else that's new here. We're going to actually shade above the line if we have the greater than symbol or greater than or equal to symbol, and we're going to shade below the line if we have the less than or equal to symbols. So let's take a look at putting all of these steps together. Okay, so here's an example. We have a linear inequality, and we need to get this thing into slope-intercept form first. So yes, we have an inequality symbol, but we can still treat it the same as an equation. You can draw that line down the middle. We're trying to get y by itself. So we need to subtract 2x. And we're left with negative 3y equals, oh, making a mistake already. Not equals, we've got our less than symbol. So we're going to keep that less than symbol there. Okay, and then we have negative 2x plus 15. Now, to get y by itself, we're dividing everything by negative 3. Now, keep in mind, we said that if we're dividing by a negative number, we're going to have to flip our symbol over. So now we have y is greater than 2/3 x minus 5. So we have our linear inequality. It's in slope-intercept form, and we can graph. So we have a y-intercept at -5, and our slope is 2/3, so we're going to go up 2 and right 3. Now, because we have a greater than symbol, we're going to connect our dots with a dashed line. And because it's a greater than symbol, we're going to shade above this line. So here's what it would look like. Dashed line, shade above, and the solutions to this linear inequality are any point that you would find in this shaded region. So any of these points that you see me putting in here would be considered solutions to that inequality. Now, when I have a dashed line, the points actually on this line are not considered to be solutions. That's why it's dashed. We're finding values that make it strictly greater than. If we had a greater than or equal to, we would have a solid line there. And then we could also say that points on the line are solutions to that inequality. So this is the general process we're going to be going through here. So let's take a look at another example. So for this one, we already have it in slope-intercept form. It's ready to graph. Now let's make a couple notes here for what this inequality symbol is going to tell me to do. If it's a greater than symbol, we know it should be a dashed line. We also know for a greater than symbol, we're going to shade above. So we'll keep that in mind as we graph here. So we have our y-intercept down at -5. And we have a slope of 1/3, so up 1, right 3. So we have our points, but before I connect, I'm going to keep in mind that I'm doing a dashed line here. So when I connect, it's not a solid line, it's a dashed line. So here it is. The last thing that we have to do is we need to shade above. So if I shade above my line, I'm going to be shading up here. Okay, so any point in this shaded region, so here, 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 anywhere that you see in this shaded region would be considered a solution to that system. Meaning, if I took that ordered pair and plugged the x and y value into my inequality, it's going to make it true. Okay, let's look at another example. So this time, we have a less than or equal to symbol. So that tells us two things. It tells us we're going to have a solid line, and then for less than or equal to symbols, we're going to shade below. So we're going to graph as usual, and then do these two extra things. So let's see, we have a y-intercept at -1, a slope of -2. So I'm going to go down 2, right 1. And then I'm going to also backtrack. I'm going to go up 2, left 1. Now, we said this time we have a solid line. And we're shading below. So if you think about this as a hill, because sometimes it can get confusing about what's above and what's below. If this was a hill, we would be standing like right here on it, okay? So we would be on top of the hill. We don't stand underneath hills. So above would be where you would stand if you're thinking about it like a hill. Below would be on the opposite side. So this time, if we're shading below, we're shading down here. So something changes now because the solutions aren't just inside this shaded region anymore. Like we've been saying, yes, these all are still solutions if they're in the shaded area, but now that I have a solid line, I can say that any points on this line, okay, even the in-between here, like any of the points on the line or in the shaded region are now considered solutions. So once you have the solid line, you can also include the points on the line in your solution set. So let's look at one more example here. Let's go back to one that's not in slope-intercept form. Okay, for number 3, see, we need to get this into slope-intercept form. So let's draw a line down the middle to split it. And we're trying to get y by itself. So we're going to subtract 5x from both sides. We're left with -2y is greater than -5x plus 12. Now, my next step here is I'm going to divide by -2, but we've got to be careful because remember, if we're dividing by a negative, our inequality symbol flips. So we have y is less than, and then -5x divided by -2 turns into positive 5/2 x, and 12 divided by -2 is -6. So now my inequality is ready to graph, but before we do that, let's make some notes here. A less than symbol means I'm going to have a dashed line, and I'm going to shade below. All right, so let's see what we get. We have a y-intercept at -6, and we have a slope of 5/2. So we're going to go up 5, right 2. And those are all the points that we can fit on our coordinate plane here. So we said it's going to be a dashed line. And we said we're going to shade below. So again, if we're thinking about where we would stand on this hill, we would be standing on this side. So below would be the opposite. Below would be down here. Now, because it's a dashed line, we're not going to find any solutions on the line. They would only be the points inside of the shaded region. And again, if I took the here, for example, this point right here would be the points, let's see, 6, 1. If I took that x and y value and plugged it into my original inequality, it's going to make it true like we saw at the beginning of this video. So I hope this video was helpful. Please feel free to ask questions, pause, rewatch, rewind, and have a great day.